everyone, welcome to another video. Today we're going to be talking about chapter 9, equation of circle. Okay, so let's start from the standard form of a circle. So this is what we call the standard form, and you can see that it's a x minus a number holding square plus y minus a number holding square equal to r squared. Now there's a reason why this is called the standard form, because from this form we can see many important things straight away. So for example, the center of a circle is AB. So A comes from actually here. When x equal to A, we got A minus A, and then the whole thing becomes 0. So it's the same story for the y. That's why from here the center is you can actually see the center straight away. So for the r square here, r actually refers to the radius of the circle. So using this form, we can immediately see the two most important things of a circle, the center and the radius. Just with these two information, we can draw the entire circle straight away. Now the next thing we're going to learn is actually how to change from non-standard to standard form. So a typical circle, they may not always give it to you in sort of nice form. So for example, you can see that if they give you this x squared plus y squared plus 4x minus 6y minus 12 equals 0. This is also a circle's formula. So how do you see? The telltale sign is this. There's an x squared, there's a y squared in the formula, and in additional, there's no xy term. You can see that in this equation over here, you only got x, you only got y, you got x squared, y squared, but there's no xy term. Okay, so these are the telltale signs that this is a circle equation. Okay, so how do we do this? So from this equation, how do we convert the equation to look like this? Actually, you can just complete the square. So let's do an example over here. So what we do is we group the x and the x together. So you see we group these two together, and we do the same for the y. And then with this 2x term, I complete the square. See, from here I plus 2 square and I minus 2 square. So similarly for the y, you can see that based on these two terms, I'm going to plus 3 square and then I'm going to minus 3 square. After I shift things around, so from here to here I complete the square, from here to here I complete the square, and then I have 5 square, everything here shift to the right. So with this done, you can see that based on this formula, it looks like exactly like the standard form over here. So just by looking, you know that the x coordinate of the center is -2, the y coordinate is 3, and the radius is 5. So you can see this is the conclusion. So let's try some question over here. So I have this equation and this equation. So you can tell that this is both of them are circle equation. So what to do is you need to find the center and the radius. And to do this, you need to express these two equations into a standard form. So and you can do it by exactly here, completing the square. So I've done an example over here. You can actually give these two a try. You can pause the video and then you can give it a try. So the answers are here. So this is the answer and this is the answer. So pause the video, give it a try. Okay, so I hope you have tried the question and you can get the answer. So we're going to move on. The next part we're going to go through is actually to find the intersection of a straight line and a circle. So actually this is nothing different from any other intersection point you will find. So in order to find intersection of anything, you literally just sub this line into the circle. As long as you sub one into the other, you're going to solve for intersection. So a circle has is no different. So you can see that we have a line here, this one, x equal to something, and then we have a circle over here. This is our typical circle. So in order to find the point of intersection, I'm going to sub this into here, meaning I'm going to replace x by 12 minus 2y. So you can see that over here we have a x square, we have an x. So the x square is replaced by this, and then the 6x is replaced by this. And after that, what I'm doing, I'm just expanding everything. I'm simplifying everything I'm at here. And then I do my typical cross method, I solved. After I solve, I got two answers, 2 and 6. I'm going to solve the I'm going to solve the 2 and 6 into the line, which is this one. And then from there, I find the 2x value. So that is the two intersection point of a line and a circle. So now that we have learned all the basic stuff of equation of a circle, now we're going to do some typical question that actually uses some of this concept that you have just learned. Okay, so let's go with this one. We need to find the equation of the tangent to the circle. This is the equation, and then which are parallel to the line over here. So parallel to the line is important because this line has the same gradient as the tangents that we are supposed to find. So again, but this is not a it's not our y equal to mx plus c. So we do not know the tangent of the gradient of this line. So we need to get the gradient out first. Okay, so this is how it looks like. From this equation, I'm going to convert it into the y equal mx plus c. So which means the gradient is -2. So where is this line? I don't know where is this line. It is somewhere here. So maybe this is the line. Okay, nobody say it cuts a circle. It can be anywhere, right? So the next thing, if you look at the equation, the question, it says that the equations of the tangent are parallel to this line, which means the equation of the tangents are also parallel to -2. So where is this two lines? So the two lines are actually over here. You can see that one line is here, one line is here. Most importantly, see this line, and this line are all parallel. You can see that they are parallel. And then since it's the tangent to the circle, this line only touches at this point and this point. So it touches the circle once. So the question is, what is the equation of these two lines? So since we know that the gradient is -2, so this has to be -2x plus c. I don't know what's the c. And similarly, this is also -2x plus c. Not the same c, maybe we put it d. So we will need to find the unknowns C and D, and we need to find unknowns. We need to form an equation. Actually, the equation comes from here. The secret word is tangent, because when it is tangent, it cuts the circle, which means these two lines, this line actually cuts this equation. So what we do is actually we sub y equal mx, y equal -2x plus c into this formula, into the circle's formula, and from there we are going to solve. So let me show you the solution. Okay, so now I'm at the solution. So all this part we have talked about already. So we are actually now here. So the tangent is going to be y equal to -2x plus c, some number. And then what I do is I'm going to sub this into the equation of the circle because they're supposed to intersect, right? So I'm going to sub in. You can see that the y square here becomes this -2x plus c. The x also become, the y also become -2x plus c. I'm going to just expand everything, blah, 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 and I rearrange. You look at what I'm doing. We are doing x squared, x, and constant. Why do we do this? Because this equation, we can't really solve it. Okay, in fact, there's two unknowns. We can't solve this normally. But since it is a tangent, we know that this equation is supposed to have how many answers? Only one. And that is why the b squared minus 4ac has to be equal to 0. So actually this is the key point. Once you are able to spot this, your so-called equation is reduced to having only c as the only unknown. Once you get this, you can find that c is 0 or c is -10, and hence the two tangents are -2x plus 0 and -2x plus 10, which is why is this one -10 and plus 0 over here, and that's why the two answers are this and this. So the next question we're going to go through is it will be this one on the right side. So we have one line, this one, and it's a tangent to the circle, and this circle has center 3, 4. So over here the center, and then the tangent is at the point P. So this is the point where they actually touches. Okay, over here. So we're supposed to find the coordinates of P. So usually, if you need to find the coordinates, you just need to sub this line into the circle's equation, right? But the problem is we don't have the circle's equation. See, they didn't give it to us. So we are a bit stuck here. So if we need to find P and we cannot intersect with the circle, there's only one other thing that we can intersect with, which is actually this line over here, which is CP. So we can find the equation of this line CP. So as with all lines, we need gradient and also one point on the line. So the line is actually pretty obvious. The point is over here, and then the gradient is actually -2 of this is -2. So since this is right angle, so the gradient is actually, let's do it side working. So our gradient is actually flip negative like that, and then the one point is 3, 4. So immediately equation of CP is equal to y minus y equal to gradient x minus x. Okay, and then you can actually find the equation from here. I've paused the video, I've done it already. So this is the equation I eventually found. I make x a subject, and this is my first equation. So in order to find the intersection point between this and this, I'm going to equate the two of them together, and I'm going to solve. So let me show you the working to save time. So after you solve the equation, you are going to get this as the coordinate. So the next part of the question is actually to find the equation of the circle. So you look, we already have the center. Remember, just in case you forgot, the center is actually 3, 4, right? So we are short of the radius. What is the radius? So the radius is actually you can already found. So we already found this. We got this. So that's why we are using the length of the line segment between 2 points, and then I'm going to get the length of here. Why do I find this length? Because actually this length is the radius. So once I get the radius, the answer is this one, and hence the whole formula will be, so it's a bracket square plus bracket square, and then the 3 and 4 comes from here, and then we got the radius. See, the radius is the one with the square root, and the square root whole thing square. And of course, if you simplify this, you get the 49/5, and that's the answer of the question. So hope you have learned something new today. From here, you should be able to do the homework. So thank you and bye bye.